1 meter wide. The crowd is 10 times wider, 10 meters across, larger by 1 power of 10. Now, with every step, every ring, we travel 10 times farther from Venice, and our view of the universe is 10 times wider. The 100-meter ring surrounds St. Mark's, and 1,000 meters, 1 kilometer, the city center. As our speed increases, 4 steps, 4 powers of 10, reveal all the islands of Venice, the Adriatic Sea, and the mainland of northern Italy. Six steps take in Europe from central Germany across Italy to the Balkans. And soon we can see the entire planet, our home in space. Eight steps on our outward journey, 8 powers of 10, and we pass the farthest reaches of human travel, the moon. If we visualize the paths that the 9 planets take in their orbits around the Sun, at 13 steps from St. Mark's Square, the entire solar system comes into view. And with 15 steps, 15 powers of 10, we can see that our sun is just another star. From here on, our voyage will be measured in light years, the distance light travels in an entire year. Only now do we fly past our nearest neighbor stars, almost 5 light years away. The same journey at the speed of today's spacecraft would last 100,000 years. As we cross the perpetual night, our voyage takes us up and out of our sun's neighborhood, near the edge of a great pinwheel of stars. The Milky Way is actually a spiral galaxy, and our own sun is just one of 100 billion stars in it. At this immense scale, 23 powers of 10, each shining light we see is not a star, but an entire galaxy, composed of countless stars. Astronomers have discovered that the galaxies are flying away from one another. The universe is expanding. Our own galaxy, and all the others, form clusters and superclusters of stupendous size, hundreds of millions of light years across. And here, about 15 billion light years from Venice, we approach the outer limits of the visible universe. What lies beyond this cosmic horizon, we cannot see and do not know. we move into the cell nucleus, each new ring now reveals a world 10 times smaller in diameter than the last. Deep within the nucleus, we come upon truly remarkable constructions, long spiraling molecules of DNA. DNA holds the chemical codes for the reproduction of most organisms on the planet, whether they're paramecia, people, or petunias. Voyaging on, we see that molecules are made of even smaller parts called atoms. The tiny world of the carbon atom is very strange indeed. Its 6 electrons seem to swarm everywhere at once. Now our voyage takes us through a void that appears as vast as the space between the stars. Ahead lies the atomic nucleus, so fantastically small that if the whole atom were the size of this theater, its nucleus would be like a speck of dust. Yet the nucleus contains almost all of the atom's mass, packed into particles called protons and neutrons. And these, in turn, are made of still smaller, mysterious things called quarks. Exploring this, the inner frontier of the universe, physicists wonder if quarks might contain even tinier building blocks of matter.